Good evening, Space Voyagers, and welcome to day 6 of the 12 projects of Codemas. If you've made it this far, thank you very much for sticking around. And if you are just now starting here, then go back and start at day 1 if you want to see how we got to where we're at. All right, let's get right on into it. All right, let's do the unboxing. So, day number 6. Alright, so looks like we have one photo transistor, 3 mel-to-mel jumper wires, and one 10K resistor. Maker Advent Calendar day number 6, looking for light. Welcome to day 6 of your 12 projects of Codemas Advent Calendar. Today we'll be using a light sensor to which, you guessed it, can detect the amount of light around it and provide us with a reading value which we can use in our code. The light sensor we're using is another analog component, which means it's able to provide a nice range of values to give us really granular light readings for our projects. Let's go. Box number 6 contents. As we saw, we have a photo transistor, one 10K resistor, and 3 mel-to-mel jumper wires. Today's project. Today we'll be learning how to take analog readings from our light sensor and converting those into something more useful, as well as some other new tricks to manipulate data and strings. We'll also make a light indication project with our LEDs. Sensors similar to these are used everywhere in the world around us, in street lamps, vehicles, room lighting, and more. They detect the amount of light, and this determines the amount of electrical current that is passed across the legs, and therefore into our Pico as an input. A great one to learn and use in many projects. Construct the circuit. We're going to use the LEDs again and also the buzzer, so leave them in place and remove everything else. Your circuit should look like this to start with. Alright, before we start with today's circuit, we must stress that you need to pay close attention to the legs of your light sensor. If you're getting the wiring wrong here, your light readings won't make a lot of sense. With that in mind, grab your mini breadboard and fit the sensor with the long leg to the left. It should look like this. Alright, so long leg to the left. Now we need to add 3 wires and the resistor. Connect the right short leg to the 3.3 volt pin, which is physical pin 36. Connect the left or the long leg to GPIO 26, which is physical pin 31. Add the resistor to connect the left leg over to another empty unused lane on your breadboard. Connect the other end of the resistor to a ground pin on your Pico. We're using the blue lane as it's already connected to ground for our LEDs. Your circuit should look like this. Activity 1, simple light sensing. Let's start with a simple starter program which grabs a light reading for us. This is just a minimal program to return the analog value once, which isn't all that useful to humans, but we'll convert it to something more practical in the next activity. In this example, we are importing ADC to use the ADC function, setting up the sensor GPIO pin as an ADC pin, creating a variable called light which reads the sensor value, and printing the variable value. Alright, fingers crossed that this works. 2704, 29, 20. Turn the light on, see if that's larger. Alright, I think we got everything hooked up right at least. Activity 2, making light readings usable. We know we can grab a single reading from the sensor with a very short program, but we really need that reading to be in a format that we can use and recognize. In the example below, we convert the reading to a percentage using a little maths. This will come in handy in one of our later boxes when we, nearly dropped a spoiler there. We'll show a few examples, as there are some other tricks we can use to make our printed values even more useful. Example 1. This example takes the reading and turns it into a percentage. It divides our reading by 65535, which is the maximum of the analog reading range, and then multiplies this by 100 to give us our percentage value. So, alright. So we sing 5.2. Turn the light on, and it's 21, 20. Example 2. This example builds on the previous one by limiting the number of decimal places, as we really don't need that much detail for something like a light reading. To do this, we use the built-in round function in our percentage calculation. You'll see this below, where we use round light divided by 65535 times 100 to the first decimal. This is taking the light reading, applying the same percentage calculation, and then the final number 1 defines how many decimal places to use. Try the example below, then try changing that last number to 2 or 3 to see what happens, and then try removing the comma and number altogether, which will remove the decimal. Alright, so try a 2 here, or 3. Example 3. Our final example adds the percentage symbol after the reading. We do this by adding some parts to our print line. Normally when we print the reading, the value is a number. In our example, it's a float to be exact, as it has a decimal. However, if we want to print that value along with text at the same time, the percent symbol, we need to convert everything to a string. The print function will not let us mix both together. We can do this by using the built-in string function, which converts values to strings. We use string light percent to convert our light value reading to a string, then add another string next to this with the plus percent. You can see this in the example below. Give it a try. Alright, so we see it's 4.5%, 5.6%. Activity 3, light level LED indicators. We've covered grabbing readings and converting the values, so let's put that to work with a nice little light indication project using our LEDs. We're going to run an example where we continually check the light readings and assign our 3 LEDs to a range of readings. Red will indicate a low light level, amber for normal, and green for high. The code. In the example below, we add our LEDs back into our code and define the pin numbers. We also define the light sensor pin before we start a while loop. The while loop grabs a reading from the sensor and converts this to a percentage like we did earlier, then uses if statements to light a different LED depending on the percentage reading, similar to what we did on day 4. Copy this over to Thani, run the code, and use your phone's camera light, a torch, or simply turn your lights off to see changes with the program. Once complete, why not try adding the buzzer code from yesterday's box? Alright. See. Alright, so low light around 4%, 5%. We see the red light is on. Shining my flashlight turns it green. As we're at around 79 to 85, 94%. And if I pull that away a bit, okay, there we go. So around 30%. we see it's amber. It's complete. Why not try adding the buzzer code from yesterday's box when the light goes below 30%? Alright, let's try adding this to here. So define pin for our sensor, define pin, set up the buzzer pin. Alright. So if the light percent is less than 30, we want this to play. And if it's not, we don't want it to play. Okay, so if it's less than or equal to 30, sound the buzzer. Everything else turns it off. Alright, so let's give it a try. So we'll start with the light on. PWM isn't defined. Alright, 96%, we're at green, no buzzer. Pull it back a little bit. 46% yellow, no buzzer. And turning the light off, buzzer and red. And as soon as we turn it back, the buzzer stops. Alright, sweet, so that worked. Day number 6 complete. Is it really? Yep. Good job, makers. We've learned how to use another sensor today, as well as introducing some new ways to manipulate values and strings. We are going to use this sensor again before the end of the calendar as a great partner for a component hiding in one of our other boxes. So what did we learn today? Today we learned how to wire a light sensor circuit, learned how to manipulate data to make it more useful to us in our programs, learned how to convert values to strings with the string function, learned how to use the round function to limit decimal places, and we learned how to combine multiple strings and prints. As always, please leave the circuit as is and wait for tomorrow's box before you remove any parts. Sleep well. And that marks the completion of day 6, so we are halfway through the advent calendar now. Come back tomorrow for day 7.